Welcome to video 4.4G, another proof using the equidistance theorem. Alright, so I'm going to skip example 2 just so the videos aren't too long. The numbering system was kind of wacky. In any event, we're on example 7. Okay, so here's example 7. Given this figure with MN, the perpendicular bisector of segment JK, A is the midpoint of JM, B is the midpoint of MK, C is the midpoint of JN, D is the midpoint of NK. I also added one more thing to simplify the proof. Also, angle AJC is congruent to angle BKD. After all that, prove that segment AC is congruent to segment BD. So I'll just put like a little segment there with a question mark. Little segment there with a question mark. That gives my brain some clear direction. All right, so just at first glance, it seems like if I could possibly get this triangle to be congruent to this triangle, I'd just be one step away, CPCTC. So that's going to be my first thing to try. So I'll just outline those triangles, and that's now my goal. All right. Ooh, I see repeated statements of midpoint. I'm thinking of maybe multiplication or division. Okay, it doesn't have to be, but I'm definitely thinking of that. All right, so as far as getting the triangles congruent, we were given, at least I additionally gave that angle there. So now I'm looking for some other things. They said that MN is the perpendicular bisector. All right, that means point M is equal distance. So that means this and this are the same distance. They then went on to say that we're a midpoint here and a midpoint there. Across the ocean, I'm definitely thinking of multiplication or division. However, I started with big segments and I want to go down to small segments, so that's going to end up being segment division. I'll be able to use segment division to get that congruent to that. And then I'll be able to do the same thing on the bottom. Point N is on the perpendicular bisector, so point N is equidistant to those endpoints. C is the midpoint of that segment, D is the midpoint of that segment. I've got big segments congruent, and then I chop each of them in half. Their halves are congruent. And then I'll get the triangles congruent by side, angle, side. And then I'll get AC to BD by CPCTC. So all of that analysis is done up front. Only now do I start the proof. Okay? I'm even going to write down SAS, just so I have clear in my mind what's going on. And I need you to support the side, angle, and side. Okay? And I'm going to try to go in SAS order. All right, so I guess I'll start with these sides here. So I'll start with the perpendicular bisector. So MN, perpendicular bisector of JK, given. From that, I got these segments to be congruent. JM is congruent to MK if perpendicular bisector, then equidistant. Okay, then I'm going to state my midpoints. So I had A is a midpoint of JM, and I had B is a midpoint of MK, given. And again, those are across the ocean. So I've got big things, chopping in half. Now we'll get their like divisions congruent. So I can say JA is congruent to KB, segment division. Or if segments are congruent, then their like divisions are congruent. So all of that for that side. Then I'll go with the angles that was given. Angle AJC congruent to angle BKD given. Now all I've got to do is repeat that same process here below. You might want to try that yourself. I'll do it right now. So we're going to get Jn to be congruent to Kn. Again, that's, just so you know, that's coming from that statement right there. All right, so that would be if perpendicular bisector, then we're equidistant. Okay, then I'm going to say those midpoints. C was a midpoint of Jn, and D was a midpoint of Nk. That was given. So now I've got the big things chopped in half. Again, I've got segment division. So I'll say JC is congruent to KD. That's going to be segment division. So I'm going to need one more step. I'm now going to get the triangles congruent by SAS. Let's get some good ordering here. So triangle, since I'm trying to go AC, maybe I'll start triangle ACJ. Once I do that, I'm stuck with BDK. And again, that would be by SAS. And then step number 10, they wanted me to get AC. Notice, first two letters, so my ordering makes sense. So AC congruent to BD by CPCTC. Whew, that was a long one. So there you have it, how to do a more challenging proof using the equidistance theorem.